Number 4, assign the oxidation number to the element specified in each of the following. So looking at this H2O2, what is hydrogen? Now, hydrogen can either be a +1 or a -1, so we really only have two choices. What I want to point out here that's a special circumstance is the oxygen. Hopefully you know that oxygen most of the time is a -2. The only time it's not a -2 is if it's either bonded to fluorine or if it's in a peroxide. Now I know a lot of you are still confused about what a peroxide means. What I'd like to remind you is that prefix per. Peroxide. Peroxide. Per means a lot. Remember our naming system we went over with the chlorite and chlorate polyatomic ions, right? We have the hypochlorite, we have the chlorite, we have the chlorate, and then we have the perchlorate. And all of those different names, all those small changes to the names, were made to indicate the differing numbers of oxygens in that polyatomic ion. The same idea is going to be applied to this per right here on the peroxide. So when we say peroxide, we are truly and very explicitly saying there's more oxygen than normal here. More oxygen than normal. So what we're actually saying here is we have always an O2, but it's bonded to a main group 1 element. In main group 1, right? 1A, main group 1, that's what that refers to. But there are 2 of the main group elements and 2 of the oxygens. Now if you remember your rules for identifying what charges main group 1 elements will form, you should remember that they're always going to form +1. They're always going to form a +1. And so we would only need 1 oxygen to balance that out. But here we have 2. We have 2. And that is why in a peroxide, oxygen only has a -1 oxidation state. -1 oxidation state. So hydrogen in a peroxide is a +1. Now just so you guys know for future reference, a peroxide are 2 atoms of any element in main group 1 bonded to 2 oxygens. Here are some examples. This is hydrogen peroxide. You guys have heard of this before. Hydrogen peroxide, lithium peroxide, sodium peroxide, potassium peroxide, rubidium peroxide, and on, I guess, for cesium peroxide and I guess francium peroxide. But these things that normally form a +1 being bonded to 2 oxygens, which is more than normal. And that's why we have the name peroxide. Peroxide. Lots of oxygens. Moving on to B, we're being asked for hydrogen again, right? Hydrogen can be a +1 or a -1. Here we see that hydrogen is bonded with a less electronegative element. Magnesium is less electronegative than hydrogen. That means hydrogen is going to pull on electrons harder than magnesium is. That's going to draw electrons in the bond closer towards the hydrogen. How many electrons does hydrogen have the capacity to draw? 1. So it's a -1. So when hydrogen is bonded with a less electronegative element, hydrogen is a -1. C, sulfur and S8. Guys, there's only sulfur here. Only sulfur means it's a pure element. And any pure element has an oxidation state of 0. D, looking at carbon in the carbonate polyatomic ion. Let's start with oxygen. That's the easy one. Okay, oxygen is going to be a -2 most of the time. There are 3 of them. So that's a total of -6. Now before you jump to the conclusion that we want to give carbon an oxidation state of -6, look at this overall charge. This is the carbonate anion, polyatomic ion. So it's got an overall -2 charge. So we don't want the oxidation state of this carbon to completely neutralize the -6. We want to have -2 left over. So instead of completely balancing with a +6, we will go with a +4 so that there will still be a -2 left over. Then chromium in what's this? Sodium dichromate. let's start with the oxygen, -2. There are 7 of them. That's a total of -14. And then there are 2 sodiums, each coming in at +1 because they're in main group 1. And so if I wanted to completely balance this out, right? Completely balance this out, which I do here. These 2 chromiums need to supply a total of +12. +12. But there are 2 chromiums doing that, so each individual chromium is going to supply a +6. Lastly, nitrogen in NO2 in nitrite. Actually, no, this is not nitrite. This is not an ion. This is just nitrogen dioxide. Right? So yeah, there's no charge here. There's no charge listed, like we see over here on the carbonate, or up in D on the carbonate. There's no overall charge, so this is just nitrogen dioxide. So let's start with oxygen, -2. There are 2 of them, right? So that gives us a total of -4. -4. There's only 1 nitrogen to balance out that -4, so we give nitrogen a +4.